Here is a deep question. Given some data, what model best explains it? The most influential answer in all of statistics is a principle called maximum likelihood. It is the engine that fits models, and it quietly justifies many of the loss functions machine learning uses every day. Flip a bent coin 10 times and it lands heads 7. What is its true probability of heads? For any guess, we can compute the likelihood, the probability that this exact sequence would occur if our guess were correct. A guess of 90% makes 7 heads plausible, a guess of 10% makes it almost impossible. Maximum likelihood says, choose the guess that makes the observed data most probable. Sweep the probability of heads from 0 to 1 and watch the likelihood rise and fall. It peaks unsurprisingly at 0.7, 7 heads out of 10. The most likely explanation for the data is the parameter that best predicts it, simple and profound. In practice, we maximize the log likelihood, not the likelihood itself. Remember our logarithm chapter. The log turns a fragile product of many probabilities into a stable sum. The peak sits in the same place either way, but the log is far kinder to compute. Maximizing log likelihood is the standard recipe for fitting almost any model. And here is the punchline that ties the course together. Maximizing the likelihood is often identical to minimizing a familiar loss. For data with normal noise, maximum likelihood gives exactly least squares, the sum of squared errors from regression. For classification, it gives exactly cross-entropy. Those loss functions are not arbitrary, they fall out of this one principle. So maximum likelihood is the hidden justification behind training. When a model minimizes its loss, it is very often maximizing the likelihood of the data. It is the bridge from probability, describing how data is generated, to optimization, searching for the parameters that best explain it. Two halves of machine learning joined. So, maximum likelihood. Pick the parameters that make the observed data most probable. Maximize the log likelihood for stability, and it recovers least squares and cross-entropy as special cases. It is the principle beneath model fitting itself. Next, the mathematics of information and the loss at the heart of classification.